Okay, so for chapter 3-1, we're gonna finally start really talking about atoms here. To begin, we need a little history lesson over the atomic theory. So we're gonna begin with John Dalton, but actually before him, let's talk about a man named Democritus. Around 400 BCE, this was roughly, 2,400 years ago? A Greek philosopher named Democritus comes up with the idea of the atom. So he has an idea that if you take something and break it in half, and you keep breaking those smaller half pieces in half, eventually you're going to get to something so tiny that you cannot break it in half anymore. And he called that atomos, which then we changed into the word atoms. But atomos is Greek for indivisible or uncuttable. Basically, to Democritus, he thought atoms were these solid spheres that could not be divided. Unfortunately for Democritus, no one believed him really. Most people believed in a guy named Aristotle, who believed everything was made of earth, wind, water, and fire. But since they didn't have, the hardcore technology back then, they couldn't prove atoms. So it took over 2,000 years, about 2,200 years, to get to John Dalton. In 1803, John Dalton finally used scientific evidence to prove atoms existed. And he basically formed 5 conclusions about atoms. The first one is he totally agreed that with Democritus that atoms are indivisible particles. So down here we have indivisible atoms. They are solid spheres that cannot be divided. There's nothing smaller than an atom. Atoms are solid, indestructible spheres. He also says that atoms for a given element are exactly alike. So let's just say the red spheres are hydrogen. Every single hydrogen atom looks exactly the same. There's no difference between any hydrogen atoms. These blue spheres are oxygen atoms. So notice every single oxygen atom looks exactly the same. There's no difference between any kind of oxygen atom. However, atoms of different elements look different. So notice the hydrogen atoms are nowhere near as big as the oxygen atoms. So these look totally different. They have different sizes, aka different masses. They have different colors, in this case I'll visualize, but they are totally different. So hydrogen is different than oxygen. Oxygen is different than gold. Every element is different than a different element. But if they're the same element, then they're exactly alike. He also said that atoms can combine to form compounds in whole number ratios. So for example, atoms can have a chemical reaction in which they combine for a whole number ratio. For example, hydrogen can combine with oxygen to make water. But it's always going to be 2 parts hydrogen, or there it is, 2 parts hydrogen for 1 part oxygen every single time. So every single water is always going to be 2 hydrogens and 1 oxygen. It's always a whole number ratio. And that's where we get the term H2O, 2 hydrogens, 1 oxygen. The last thing he said was that in a chemical reaction, atoms of one element cannot change into a different element. So you can't have a reaction between hydrogen and oxygen, and some of the hydrogens will turn into oxygen, or none of the oxygen will turn into hydrogen, or you can't even combine, let's say you can't combine oxygen and hydrogen and make lead. You can't do that. Elements cannot change into different elements, according to Dalton. Now, almost every single one of these is completely wrong. Almost every single one of these, which we're going to learn later on. So, and that's basically it for all of Chapter 3, Section 1. It's just a very, very quick introduction about where we started getting the idea of atoms. So again, the main ideas to focus on, we have Democritus, who comes up with the idea of the atom, then John Dalton, who's the first to propose it, with his 5 conclusions about atoms. Again, atoms are indivisible. Atoms of one element are exactly alike. Atoms of different elements look different. Atoms can combine to make compounds, which are whole number ratios, and you can never change elements of one atom or atoms of one element into atoms of a different element. And that's it.